For example 1, we like to factor x squared minus 12x plus 35. So I want to take the approach of not using factor by grouping. So to do this, we can set up a couple of parentheses and just think about numbers that will work if we go backwards. So like, all right, we have to have the product of two pieces, both have to have an x in it, and we just need to come up with a couple of numbers. One that multiplies to a positive 35, yet add to a negative 12. So maybe off to the side you can think about, well, for 35, what are numbers that multiply to it, yet would add to a negative 12? Well, they both have to be negative, so I'm thinking maybe negative 5 and negative 7. I can actually see that this is going to work. I mean, if I add those two things together, I definitely do get negative 12, and the product is a positive 35. So let's plug them in and see what we get. That's going to be x minus 5 and x minus 7. So I'm just going to check my work to see if this is in fact correct. So if I multiply my x's, I get x squared. Okay, now if I distribute this x to the negative 7, I get negative 7x. And now I'll just continue with this negative 5. Here I get negative 5x, and then I get positive 35, and I know my work is correct. It's x squared minus 12x plus 35. So you don't have to check your work every single time, but if you're looking to factor a trinomial, something with three pieces, look to the last number, think about its factors, and choose the ones that add to the middle term. All right, same idea for the second example. I want to factor this expression, but it looks a little different. It's still a trinomial in that it has three different terms, but now I see an x to the fourth, and the middle term has an x squared. But I'm still going to try to use the same trick that we used in the previous example, where if I can split this into two pieces, what do I fill in for the numbers and the variables? Well, if you start with just an x and an x, I know that's not going to work because it only gives you an x squared. So if I actually increase the exponent on both of these to x squared, now it should work out because we'll have x squared times x squared, which would give me my x to the fourth, and the middle terms should have an x squared associated with it. So now off to the side, again, I'm just going to think about this negative 24. So I want factors of negative 24 that add to a positive 5. All right, so since this number is negative, I could go back here and say, well, I have to have a negative and a positive. The product of those two numbers will be negative. So, all right, let's see. Factors of 24, well, we'd have 1 and 24, maybe negative 1 and positive 24, but that's not going to work. There's 2 and 12, it's not going to work. There's 3 and 8, and okay, this is starting to look promising, where if 3 is negative and the 8 is positive, this would give me that positive 5 that I'm looking for, yet it would multiply to a negative 24. So let's fill this in and see if it's correct. That was negative 3 and positive 8. And at this point you can check your work much in the same way by distributing the x squared, then distributing the negative 3. I'll write that out. We have this times this, which gives me my x to the fourth. X squared times my positive 8 is 8x squared. Then I have negative 3x squared and negative 24. And by combining like terms, I see I do end up with my expression in the beginning. So here's my final answer. It's this portion here. So again, you don't have to go through all this effort of checking your work. Really, you could just check the middle numbers. I know negative 3 and this positive 8 would give me my 5, and the negative 3 and the positive 8 would give me my negative 24. All right, so for example 3, same idea. I have a trinomial, something with three terms, and I'd like to factor it. And all right, this is starting to look kind of complicated. I do see that I can take out an x from every single term. So Like here, there's an x cubed, x squared, and an x. So I can remove an x from everything. I think that'll be a good first start. So I can factor out an x, and what is left over is 12x squared plus 41x plus 35. At least this way, now I have something a little bit easier that I can try to factor. Like, I'm done with this x. I can now focus on dealing with this portion here. And let's see, there's a 12, a 41, and a 35. I don't think there's any common factors between these. I believe 41 may even be prime, so there's like not something that I can take out that's a number, so I think we're kind of stuck with dealing with this 12 and this 35. So as we saw last week, if I'm looking to break this up into an expression like this, we could take a guess and check approach where I could think about this 12 and this 35 and just try to fill in things that work. So let's see. For 35, so right here, I know we have options like, well, you could have 135, you could have 5 and 7, and for 12, okay, there's a lot more here, but we have 1 and 12, we have 2 and 6, we have 3 and 4, so this gives us a place to go. Maybe a good first start would be, I see that everything here is a positive, so I'd have to have something plus and then something plus. Now, the number in front of the x's has to multiply to the 12. So that's what I'm going to use this portion over here for. Like, I could put a 1 and a 12, a 2 and a 6, and perhaps a 3 and a 4. So I'm not really sure where to start. I'm just going to make a guess. I'm going to try 3 and 4. That will definitely give me my 12x squared. But what numbers would have to go here and here so that I get 35, but more importantly, when I add my middle terms, I get a 41. So there's not a whole lot of options. I could do a 1 and a 35 or a 5 and a 7. And I'm guessing it's probably going to be the 5 and the 7, because this 35 might give me something that's just too big. So I'm going to try, and this is just a guess, I'm going to try 7 and I guess 5. And I don't know if that's right. I'm just going to see if it worked. So, all right, I'm going to multiply the 3x and the 4x, which gives me my 12x squared. I know the 7 and the 5 gives me my 35, but I really care about this 41. My middle terms, I'm going to get 28, and I'm also going to get 15. So I'll think about that. I have 28 and 15. That's not going to work. The sum of those two things is not 41. So I know my guess was wrong. So now I'm just going to go back. I'm going to erase the 7 and the 5. So let's see. Get rid of the 7. Get rid of the 5. And maybe I'll just flip it around. You know, I could have it the other way. So I'll go with 5 and 7. Let's check that out. Okay, so this time, I'm just checking the middle terms. I'm going to get 20 and 21. Okay, this is looking really good. So for the middle terms, like I said, we get a 20, we get a 21, and what do you know that adds to 41? This is it. I could, actually multiply all of this out to take me back to the original expression, but by checking the middle terms and getting 41, I know the 12 and the 35 also work, so this is a guess and check approach. It's not a fast way to do it, but I started with 3 and 4, and then I was left dealing with the 5 and the 7. It might have taken me a little bit more if, like, maybe it was 2 and 6, and then 7 and 5, or 5 and 7 if I reversed it. But so you could use a factor by grouping approach, but there's nothing wrong with guessing either. Like, you might even get really fast at solving the problem this way.